All right, give folks a few more minutes to join us. Welcome. If you are joining us for the first time, say something in the chat. If you're here again, also say something in the chat. It's good to see everyone joining us this afternoon to talk about computer vision here at Viam. Has anyone in the audience tried using computer vision before, with or without Viam? If you can give me some response somewhere in the chat there. That's all immediately on it. Okay, cool. Using TensorFlow in the past. All right, as people are joining in, we're just kind of talking a little bit about folks who have used computer vision in the past, either with or without Viam, maybe manually. We have someone who said they used TensorFlow in the past. Maybe you've made your own model. Maybe you've used an off-the-shelf model. All right, well, we can go ahead and get started. Thank you, everyone, for joining today. For those that don't know me, my name is Nick Hare. I am a senior dev advocate here at Viam. And before joining Viam, I had never done anything with computer vision. I didn't really know where to start with something like identifying objects within an image, be able to classify them, anything like that. And one of the first things that really amazed me when I started was seeing how approachable and accessible be able to use cameras on a device, whether it's a laptop or a webcam attached to a single board computer, or even one of the an RTSP stream from a remote camera, or even one of the CSP like Pi cameras attached to a device. Taking any of that and then be able to process that image and identify objects from it, or even training a custom model to be able to do that for me. It's really nice how I hesitate to say easy, but just how, again, approachable it can be to understanding what's going on and be able to just start using it in a project. You don't have to, be a computer science major or a ML researcher in order to get started. And yes, we'll be kind of following along a little bit with our documentation that has all shared in the chat. And I'll go ahead and switch over to that now. All right, so for those who have never used computer vision in the past, you can find it here. It's one of our various machine learning capabilities with the VM app and the platform. And so we can use, a camera stream from attached to VM in order to, or any sort of images really that you can get from anywhere, whether it's stored on device already or that you're capturing in real time, in order to provide three distinct sort of services using what we have called a vision service. And so starting with detections allows you to actually find or detect objects within an image and give you the rough approximate area of where the model thinks that that the item that it detects could be. So it will give you a sort of class name or a label that's matching for the things or things that it detects within the image, as well as the what we would call a bounding box. So we can see here the XY coordinates for the minimum max for that bounding box. And you can see an example here. A dog is recognizing the image with a confidence level of just over 70%. And it's giving us a pretty good accurate box around this. And so you could use these coordinates in order to, maybe go towards whatever it's detecting, maybe go away from whatever it's detecting, be able to do something with those directions, as opposed to when we have something like a classifier or using classifications. And so classifications will take the whole image and give us a set of labels, or maybe even one if that's all you have in your model, in order to tell you what is this image classified to be. And so by finding that classification, it's only going to give you what it thinks it could be, or a couple of different items there, and that confidence threshold as well. And so that confidence can be between 0.0 or 1.0, meaning between like I have no idea or I'm super sure. And so classifiers can be generally quicker because it's just giving you a rough image, like classification over the whole image versus the detections, which are going to try to break down different parts and segment this 2D image. And I say 2D because we also have segmentations, which can, if you're using a sort of 3D enabled camera, depth camera, like the Intel RealSense, or I think the Oak D is another one that we support. You can identify within 3D space the parts of objects within the image. And so if you want to know like how far away it could be from the current, where the machine is at, that can be very helpful as well. 3D segmentation can be really helpful with point clouds for all sorts of things. But in this case, for a vision service, be able to, again, not only find that bounding box within the 2D space, but also 3D space and seeing like the distance from, the camera itself. And in order to use our vision service, you need a machine learning model behind it. And whether that model is connected to a machine learning, like a ML model service, or one of our pre-built vision services, you can, so we have ML model service. We also have various built-in detectors and segmenters that you can use without having to attach another uploaded or provided through the registry machine learning model. And so we have, outside of the more customized ML model, we have the color detector, that point cloud, the 3D segmentation, as I was talking about before, depth from just basic depth cameras, and obstacle distances, because we can also use various obstacle sensors as cameras of sorts in order to provide service for our vision service. And these are some of the other vision services that we have built into the registry that you don't necessarily need to have a, bring your own ML model with you. So we've had folks show off some of our facial detection before, using third-party tools like RoboFlow or open source projects like YOLO in order to provide this vision service as well. And so before I continue, any questions on the overall, like what is a vision service and what can you do with it? As any questions roll in, I will notice them in the chat, or Hazal will give me a heads up and we'll start answering them. So let's start with some of the basics for just getting started with using the vision service. So I've already created a machine within my org, which I'm labeled as the office and at my desk right now, and it's just running on my laptop. So my MacBook Air right here is running Viam server. It's currently live and connected, and I have nothing configured at the moment. So just to get started, I want to be able to use my live webcam in order to detect me or a person coming towards my laptop. And so just to get started, let's configure a camera. And so I'm going to configure a webcam because it's built into my laptop. It's one of the easiest ways to just start getting image feedback. I'm just going to name it cam. And so with Viam server running, it's automatically going to detect any available cameras on my system, including the one built into my laptop, the one I'm actually speaking to right now on top of my monitor, or even one of the interesting things with Mac OS and iOS is that I could use my phone as a camera as well. So if I wanted to be able to put, my phone or another device as connected to my iCloud account as a camera, I maybe have a spare phone or something like that, or an iPad, I could place that somewhere else within the network in order to use it as a remote camera. But I'm going to use my webcam for now. And so let's save that. And just to make sure it's working, go over to my control tab here. It's going to take 1 second. There we go. See it pop up. And we can see there's my webcam over here off to the side on my laptop as I'm speaking to the webcam on top of my monitor. And so from there, we want to be able to detect some things, detect people in general. And so I'm going to create a service, And I'm going to create an ML model service in order to pull in a model from the VM registry that has already been trained to detect people, among other things. And I'm just going to name it people model for now. And we can see a couple options between deploying a model to the robot, or if I already have one on the robot that I've deployed before, trained somewhere else, or what have you, I can point to that instead. But for here, I'm going to search for one from Viam Labs, which is our internal sort of development incubator, how we work on various things. And there's one called the Efficient Detect, COCO. And from here, I'm going to use the default number of threads. This is really more important as you start to maybe tune it for certain usage on various devices. You don't have to worry about it right away, especially on a laptop like the MacBook Air or any other laptops. They're pretty powerful enough for these sort of things. And so I can save this, but I can't do much with this right now, especially in terms of, detecting images. So in order to support that, I can go through and search for a Vision ML model service. And we'll call this my people detector. And once that's created, I can also go and configure it to select the ML model that I had before. And if I hit save config, that's great. But now how do we test this? Well, maybe in other ways, I would have to now go and program something or to get the image and then see the output somewhere. But one nice thing about just staying within, we have this whole control tab, and we can create what's called a transform camera in order to preview what the vision service is seeing in real time, or however often we want to have that refresh coming from the control tab. And so I'll call this people cam. And we can see it's a transform camera. The source is going to be the actual video source that's coming through. So transform camera is basically a proxy. It's a virtual camera, a virtual device that will take in a source, in this case, my webcam called cam, and then process that image through some pipeline. In this case, my pipeline is going to be of type detector, because I'm going to be detecting, or actually it's called detection, I believe. Let's confirm that. Yep. And I'm referencing one of our tutorials right now, just as a refresher, because can't memorize everything for all people. It's person detection security bot that sends you photos. So if you want to check that out, we'll share a link, but you can also just find it in our tutorials on our doc site. And so we have a detections pipeline, which we're going to configure to use what is the next one called? The detector name. In this case, my detector was called people detector. And then I can set my confidence threshold on when it should actually show me a bounding box or not. If I don't include that, let's just see what happens. So with all that configured, let's save this. Go over to Control tab. You can see I have two cameras here. So my normal camera, still just kind of looking through that. Or I can see, oh my gosh, look at all that. It's trying to find everything. It sees, I think, person, something, remote, maybe remove, couch, book, a bunch of stuff. So let's tune down that noise a bit and set our confidence threshold. So confidence threshold, let's just say 50%. Like if you're kind of sure about this, then show me something. Save that. Go back here. Gonna rebuild that transform camera. Oh, actually, I think Confidence threshold. Oh, I set it as a string. There we go. It should be a number. So now we can see it's created. You can see, hey, it's pretty confident that I'm a person, which is nice. It's only like between around 70% confident, but we'll do what we can with the microphone in my face. If I were to cover my face a little bit, we can see it kind of goes down a little bit off to the side. If I put my hood up, let's see if it affects it at all. No, it's actually more confident now, it seems like. And so now we can see that we can see that, oh, it's working. It's identifying something that, or pretty confident as a person. So that's great for previewing it. But now what do you do in order to, react to something like that programmatically? And so we have our available SDKs to be able to program something to use for some sort of logic to react to detecting a person or detecting anything that it would come up with. And so I'm going to try running this and seeing like that it actually pulls back the camera. And we can see, even though I configured a detector, the sample code is going to show us get classifications from a camera. We're going to change that up, and we'll go over why it's doing that. It's doing its best guess to pull in the right sample code to be using it. Because there's no configuration really on the vision service to say it's a detector or a classifier that's built into the model itself. And so go back to our code sample. I'm going to pull up my editor. We'll have that open over here. And so I'm going to create a new quick Python project. Let's make sure that you all can actually see my editor as well. And so I'm going to make a new directory. Let's call it Viam Vision, and turn up the. And so I'm going to go into my Viam Vision directory here, and I have Python installed already. I'm going to create a quick virtual environment for all my stuff to make sure things don't get mess with my system requirements and things like that. And so I'm going to create something called Viam. It's my virtual environment for Python. And we can see here .viam, and I can make sure that I'm using that virtual environment through source VM bin activate. And this is, again, stuff that we see here on how to get started. And so I can now, if I see which Python, it's now pointing at that virtual environment Python and not my system Python. Same with which pip. It's going to point at that one. And so we'll get started by installing the Viam SDK. And then I'm going to create a new program. We'll just call it vision.py. Going to copy this here. And we can see we have our VM library being imported. We have this async IO, so we can run an async Python program. We have a robot client. Credentials and dial options are actually no longer needed because we can set up all of our options through this nice convenient with API key method off of the options class. And so I'll get these in a second. And then we can see here we're going to instantiate a camera that's coming from our VM components camera called cam. So it's already going to align with this camera name here, just pre-fills that for us. We can get an image. We don't really care about getting an image right now, so I'm just going to comment that out. What we're looking for is, and even say with the people cam, we're going to try to detect through our vision clients. So our vision clients comes from our, again, VM services vision. And this is how we can communicate with a vision service running through Viam server. And so this is already pre-filling the name of our detector, being that people detector. And then from our robot or our machine that is running the VM server. And so, excuse me, the let's see, um, detected people might be a better name for this. And we're going to ask for get detections from camera instead. And our camera name is actually called cam, as we saw before. And there's no other. So we can see here from the type description of get detections from camera, all it really needs is camera name. And so this is a shorthand for if we wanted to control getting, when we got the image, we can say image here. And if we didn't want to use the get detection from camera, we could say detected people equals await people detector dot get detections here. And so we can see from my editor feedback that all get detections needs is an actual image. And so I could pass in image here. And so just to confirm, image is get image is going to return either an image or a raw image, depending on the configuration and the MIME type that's set there. So this is just a shorthand for that we had. This is the long way of basically doing what this is already doing for us. So since we don't really care about what we do with, we don't need the image itself. We just want to pass it straight to the detector. We'll get rid of these things and we'll look at detected people. And we will see the detected people output here. And we're going to update this to make sure it matches. And then we'll close up the robot. And this will all run through that async IO context. And so in order to do this, I need to get my API key to talk to this. And so I am actually going to get this from the environment just for safety. Not that I don't trust you all on the call, and I'll roll over my API keys just in case. But this is a nice proof of concept. So we have a question in the chat. Can we do these on Windows OS as well? You can using WSL or Windows Subsystem Linux 2. I'm not sure so much about detecting the webcam, so your mileage may vary. I don't have a Windows, so if you're able to test that and let us know, that'd be great. We can update our documentation to confirm that. And so I'm going to set up API key here, and I'm going to use os.get env, and we're going to look for Viam API key. And then I'm going to set up my API key with underscores. Os.get env Viam API key ID. And this is a great way to configure using the API keys if you want to share a program later, you don't want to forget to actually commit it. And so we're going to pass those through here. And I'm going to save my program and quit. And I'm going to stop sharing my screen for just a second while I set my API keys up. Alrighty. And now let's try running our program. So I could do Python vision I. Oh, so we got an error saying badly formed. Oh, be an issue with my API key. 1 second again. I see the problem. I set API key and not Viam API key. I'm going to reset that to Viam API key and to the Viam API key ID. And come back to this. And let's try that again. All right. So if we take a look at here, we got a lot of stuff back. And so we got, pardon me, we can see going from, it looks like all sorts of confidences, but it's ordered by most confident to least confident. We can see that at this D's bounding box, so x min 191, and the bounding box itself is based off of the image size that you give it. It's going to be within those coordinates. And I think it's relative basically from the I think top right or top left. I think it's top left and then going from there. And then we can see the confidence level here. We have quite a few different detections around person, remove, couch, book, chair, scissors, chair, TV, remove, cup, all sorts of things. So if we want to reduce that sort of noise like we saw before, get detections from camera doesn't have any sort of way to built in, but we're using Python. We can loop through this and be able to figure that out by filtering through the list. And so let's say we're going to find people for, or let's say person for person in if person dot confidence greater than 0.5. So I think this needs to go to the end here. So let's try running that. And so now we can see it only returned that one person from the list that it detected. I could also say if I just wanted to detect people, I was just going off of confidence altogether, but we saw it detects more than that. So I can also say and person dot class name equals person. And so let's just try taking this away first and see what we return back, because we only want to detect people. And we can see it detects a lot of people, but it's not very confident in all of them. And so we can go through here, return back our confidence, run that again, and see we're only getting back person. And from there, I could add in various logics. So if detected people dot or len people greater than 0, then we could say print, I see you. And we can see we have our I see you here. And from there, you could use that to activate a servo, read from various other sensors, react to the environment in another way. Even potentially, if you had taken the image before, save it somewhere. If you want to save pictures of people, or as in with the security robots example, send that photo as an alert and start to really affect the environment now that you've been able to detect people within the environment itself. So that's the basic walkthrough of getting started with any sort of vision service, especially including one that includes a machine learning model. I see we've had some conversations in the chat around the passing of a webcam to WSL, but no camera support yet. Thank you for confirming that, Tolga. And then there's USB pass-through support, but again, no camera for reading from USB cameras just yet. So thank you for confirming that. Any other sort of things we want to walk through, things to talk about in terms of using a vision service, getting started with it, or how to interact with it using one of our SDKs? We see Sir Walter typing. How's it going, Azal? And if you all ever have any questions later on after this, you can always join any of the discussions within the chats or within the Discord, or if you're doing something for a challenge using a vision service, we have a specific AI challenge channel as well. And so we see how real-time is the computer vision service. Is it like in milliseconds? How can I test for this? So that all depends on the device you're using. As we saw from the control panel and even from running the code, it's pretty quick when it's running on a substantial, a laptop, which can be, depending on the model itself and how many things it's trying to classify, and how detailed it might be, how much training data it had as well. It could be very, very fast on almost any device, or it could be fast on something with a good amount of RAM, but maybe just slightly slower within, maybe still sub-second, but it might take over, a few hundred milliseconds to get some sort of response back. And then you could, maybe go and tune that even more yourself using either our model training, if you want to train it on something specific, like we were showing before. The people detector is a very general model, which is trying to detect more than just people, which means it has more training data, it's a little bit larger, has more to process through. And then if you were just to look for people or not people, it could be quicker if that's all you really cared about. And you could find a more fine-tuned model for that. And hope that helps, Sir Walter. You can test it on all sorts of devices. I think running it on real hardware will be the best test for how quick it can be. Professor D, is the API call to the ML service cached? So are you referring to when I run the Python SDK and then getting that response back from the machine learning service on the device itself or wherever Viam server is running? Yes. It is not cached. It is going to be, trying to make that request each time because it's going to get a fresh image, pass that to the vision service, and get inferencing from the underlying machine learning model, and then feeding that response right back to you through the SDK over our real-time connection. Thanks for asking, Professor D. And we have several other sort of tutorials that show off within the, you can see how to go and train a model using data that you've captured from a device. Either you could upload it from the VM app onto into your org, or you could capture it straight from a webcam on your laptop or wherever, using our data syncing, data management service, and then going through and training a model. This is the more recent one that's a lot of fun that Matt Vela set up on how to monitor for, a hard hat or no hard hat, and using, you could just use a standard webcam. Yes, thank you, Hazal, for sharing that in the chat for the filtered look of the tutorials. And for Matt, he was using the YOLO V8 modular service rather than a model from the registry like I was. And so you can see how he's using that together with a set of other third-party services like Google Cloud Functions, SendGrid, in order to get alerts around this sort of stuff. Another one that we were talking about a bit before was facial verification, facial detection. And this is using, again, some of those pre-built services that we have for facial detection and people detection. And this is another great one to show kind of how quick it can be depending on where it's running and what device it's running on. We can see that it's got a countdown before it starts fully detecting. And then as long as disarmed by some dude, so it's recognizing a person in order to disarm it. And it took maybe a second or two to fully react to that. And this is, again, running off of a webcam that's mounted to parts of our office, actually, in this case. So I think it's kind of incredible. Tipsy is another great one that Hazal put together back last year on using people detection in order to go and towards people in order to bring drinks and also roam around to continue passing drinks around and trying not to stay next to the same person. And these are all things that you can go do as part of your project and make it a bit more personal, a bit smarter along the way. That's all I really have for my part of this presentation. I'm still happy to take questions. We're available for the next 15 minutes if people still have some stuff that they want to ask questions around a project they're working on, and I'm happy to help answer them. Something coming soon that Hazal will be sharing through the community newsletter and other announcements is some office hours coming up with me and Matt Vela to help kind of troubleshoot with you or maybe talk through some of the feasibility and some of the technical bits of your AI challenge projects. So keep an eye out for that. A question from Vladimir. Is it possible to use more models from TensorFlow.js? So if you're asked, so TensorFlow.js, as far as I know, uses TF Lite or TensorFlow Lite models, and we have those available in the registry, as well as we just recently started shipping the ability to use ONNX and PyTorch and full TensorFlow as part of the ML model service. And so you can go through and upload a model that you'd like to use to the registry to use on your device, or if you want to pull it down using the Hugging Face CLI on your device and use those, you can use that and then use it as part of our ML service. And so let's take a look real quick. So we have ML models, and we can actually see it's located within here. We now have the ONNX CPU model service that you can use to inference with ONNX types, or as discussing before, TensorFlow CPU to run full TensorFlow models through the CPU. And then PyTorch right now is limited to GPU, as well as we think we have support for full TensorFlow on the GPU for Triton server for NVIDIA Jetsons. But yeah, there's nothing stopping you from using models that you can find on Hugging Face or Kaggle or any of those sort of repositories that and open source communities that have models to be used. And it's good to go and start deploying them onto a device and start testing against, again, the hardware that you're using. Sometimes, Matt and I have been working with a lot of various big, large language models. I've been working with a lot of local speech to text, text to speech models that can run super efficiently on my laptop, but could be not as efficient on a single board computer like a Raspberry Pi or an Orange Pi or any of those devices. So it's worth testing. Sometimes a little bit of latency can be okay for your use case, especially if you are trading off offline ability with sort of maybe power that could be used through a remote service, like OpenAI Whisper or anything like that, or 11 Labs. I hope that helped answer your question, Vladimir. Awesome. Well, that's it for me. Professor D, one more thing maybe. Oh, thank you. Thank you all for joining today. It's been great. We're really excited about what we all are building for the AI challenges, and we can't wait to see what you've done. We're always trying to keep up to date with making Viam as useful as it can be. It is very flexible in what you can do, especially with the ability to upload custom models and everything. And we're very hopeful that it can be very useful for you and your ideas. We will have the office hours schedules shared either this afternoon or tomorrow. We're putting those together now. And then at the latest, we will be able to share those next week. Is all. And thank you everyone for joining us today. It was great to see you. Have a good rest of your day and a lovely weekend as well.